Welcome to Get Your FRQ On. This question is from 2004, Test B. It's question 5, and it is not calculator active. In the question stem, we are given a differential equation. In part A of the question, we are asked to sketch the slope field at the 12 given points. With any slope field question, the first thing you're going to want to do is use the differential equation to determine the slope at the given points. So use the equation dy dx equals x to the fourth times y minus 2 to find the slope at each of these 12 given points. Then use those slopes to sketch the slope field, and then sketch the slope field. In part B of this question, we are asked to describe all points in the xy plane for which the slope is negative. So if we analyze the differential equation dy dx equals x to the fourth times y minus 2, note that the x to the fourth term will never be negative. It might be 0 if x is 0. In fact, it will be 0 if x is 0. But any other time, the x to the fourth is going to be positive. So the only hope this has of producing a negative slope is for y minus 2 to be negative and x not to be 0. If x is 0 for some value that satisfies y minus 2 is less than 0, then the slope is 0, and this question is asking about the strict inequality where the slope is strictly less than 0. So we have to exclude x equals 0 here. All right, so solve the inequality, right? dy dx can only be negative if y is less than 2 and x is not 0. In part C of the question, we are asked to find the particular solution, y equals f of x, using the initial condition that f of 0 is equal to 0. To solve differential equations on the AP Calculus AB exam, you pretty much have to use separation of variables. It's the only method that's typically taught in AB. It's the only method that they're going to test, aside from just basic antiderivatives. So use separation of variables here. Right? We're going to use the equation dy dx equals x to the fourth times y minus 2. Separate the variables, gets us dy over y minus 2 equals x to the fourth dx, and then we anti-differentiate both sides. After anti-differentiating both sides, we get the natural log of the absolute value of y minus 2 equals 1/5 x to the fifth plus a constant. Exponentiating both sides, we'll get rid of the natural logarithm, and now we have the absolute value of y minus 2 is equal to e to the 1/5 x to the fifth plus the constant. And then this is where it kind of gets tricky. At this point, the expression y minus 2 could be positive or negative. We don't know. What we do know is in order to remove the absolute value, we have to account for the ambiguity of it being positive or negative some other way. To do that, we're going to remove the absolute value symbols from y minus 2, and we're going to tack on the plus or minus on the side with the exponential, which gives us y minus 2 is plus or minus e to the c1. In this case, I haven't finished solving for c yet. I'm going to use a big C later. Y minus 2 is plus or minus e to some power times e to the 1/5 x to the fifth. Okay. Now, using the initial condition, right, plug in 0 for x and for y. Now I have negative 2 equals plus or minus e to a constant times e to the 0. E to the 0 is just 1. Now I have to be really careful about how I pick this. Recall, e to a power will never be negative. You can't say that e to the c1 is negative 2. That's not true. You have to choose e to the c1 to be positive 2. in order to get it to be negative 2 and be equal with the left-hand side of the equation, we pick the negative sign from the plus or minus in order to guarantee equality on both sides. So my particular solution is then y minus 2 equals negative 2 e to the 1/5 x to the 5th, which means that y is 2 minus 2e to the 1/5 x to the 5th.